Oh, there you are. Yeah, I sure was going to tell you about calorimetry report. Anybody want a cookie? Okay, I'll eat it then. Nobody wanted it. Okay. So, how do you write up the calorimetry report? Well, we already did one write-up for the Finding G report. And it's not that much different, same kind of sections. First, you have an objective section. Now, I'll give you this much of a clue. There are 3 objectives. All right? 3 objectives. All right, 1 for each section of the lab. They all have one overarching objective to them that involves calorimetry. Now, this is a good cookie. The whole principle of calorimetry, everything you learn. What? It's my cookie. Let me eat it. It's based on a very simple principle. All right? And that's where you have to start. That should be in the objective too. Okay. Now the theory section. The theory section is where a lot of people lose points because they get lazy and they just copy those equations out of the manual. Where did those equations come from? Well, those equations are derived, all right, from 2 things. One is a first principle. 2 things. Okay? Now that's what I was talking about when I said the objective has to have that one overarching thing about what it's based on. So there's that. And it's something that we use in a lot of these labs. And for example, when we were talking about elastic and inelastic collisions, we kind of used it a little bit. Conservation of energy. Then it's based on a fundamental equation. So you got the first principle and the fundamental equation. 2 things. What's the fundamental equation? Well, if we wanted to figure out what kinetic energy is, we know that that's equal to 1/2 mv squared, right? And potential energy is equal to mgh, right? Right? Yes, I knew you could agree with me. Thank you. Alright, so what's the equation for heat energy? You know what it is? I'll let you look it up. Get it? Okay. And what it is that Q, which is heat energy, like Ke is kinetic energy, Q is equal to mc delta T, where m is the mass, C is the specific heat of the material, and delta T is the change in temperature. So come over here. Come over here. I gotta find something to write on. Jury summons, parole board hearing. Here it is. Okay, so what we know is that this is what it comes down to. The sum of the Q's is going to be equal to 0. Where did that come from? Well, that came from that conservation of energy idea. And we know that Q is equal to mc delta T. So if you have 3 substances, you know that m1c1 times Ta minus T equilibrium plus m2c2 Tb minus T equilibrium plus m3c3 Tc minus T equilibrium is going to equal 0. And that's really all the fundamental equations, the way that you can, using that you can derive the first part, the equation for the first part. That's pretty easy, isn't it? What do you think? Yeah, I think so too. Alright, so come on back. So then for the second part, what's different about the second part? That's right. There's ice involved. And not just any ice, but solid ice. Yeah. There's solid ice involved. Sure don't want to eat this cookie? Okay. I'll finish it myself. So we have an additional term in there. So here we're changing it around a little bit. What we're going to do is we're going to add that equation into there. You can figure out how. It's not too hard. It's a different Q because those MC delta T's don't involve anything changing phases. That's a big hint. So there's a special heat formula for when a phase change happens. Big hint. You put that into your equation there, and you solve for the heat of fusion. Okay. Very good. Remember, we're still in the theory section. Your theory section shouldn't have any of your data in it. That's another big mistake that people made. I don't want to see any calculations with the actual data you got from your experiment. I just want to see a general theoretical approach that will give you those same formulas that you ended up with. The objective of the theory section, as opposed to the idea with the theory section is to come up with the formulas you're going to use. So for the third part, the theory for the third part, there you use it's similar to more to the first part than the second part, but there we're going to be solving for the specific heat of one of these materials rather than trying to figure out an equilibrium temperature. Okay? So again, it's really just some algebra. Okay, so we got objective and we got theory. Procedure, just reference the lab manual. Part 4 is the data. And the data should come next. I don't want to see anybody putting it on the end. It's all nicely done, formatted like a lab report should be done. Alright? And that's just your data sheet from the lab. That one sheet from the lab. Okay, so the fifth part. Hi. The fifth part is conclusion. Well, what do you conclude from all of this? Don't forget your sources of error. This is the thing that people forget the most in conclusions, is sources of error. They don't write any of them down, and I say, you got to include your sources of error. And you guys had lots of sources of error. Okay, a couple other notes. Remember this. When you write this up, it should all be done into a Word document, and you should email it to me. The sooner the better. Okay? No hard copies on this one, just email. Alright? There's no drawing or anything like that. No drawings that you have to do or graphs, I don't think. Yeah, none of that. You should all be able to handle it. Okay? You're all in college. So you should be able to handle using Microsoft Word to put together a report. Okay? Don't want to hear any complaints about that. Any questions? Oh, that's right, I forget. This is a video again. You can't ask any questions. That's why nobody wanted to eat my cookie. Oh, wow. Okay. So, I'll see you in the physics lab.